Today, we're going to look at how to do a 3-view drawing of this tower, right? The tower right there. Now, I'm really going to concentrate on just drawing the part down here where the planes of projection. I have this glass box right here in relation to the tower. Now, looking carefully, you see that the front plane of projection, I'm choosing this side closest to us, as my front view. And the front plane of projection is parallel to the base of the tower in that front view. I built a tower with an equilateral triangle for the base. You can see that. And importantly, by definition, if you've got the front plane of projection parallel to that front view, the right side view is not going to be parallel. It's not acceptable to adjust the angle of the plane of projection. Orthographic projection specifies that these two are at right angles to each other. Okay? And so we'll start out by, let's see if I can, I'm going to try to put this on the stand here and still get a good view. Okay. And as we know, we look on this with, we visualize this with projectors, lines of sight that are perpendicular to the plane of projection, right? So I can see right here that here's my projector, and I'm going to line it up right here with the place that projector would match up with the edge or the corner of the tower, right there. And I'm going to make a mark right there. All right. So that's going to be right there. Okay. And I purposely put a piece of wood with paper on it underneath the tower to bring it up off the surface of the table. So it's easier to see the the actual piece of wood that goes across the bottom there. I do the same thing here. I'm going to put a mark right there where the projector would intersect with the thing. And now, since we're gonna do an idealized version, when you do your tower drawings, you can pretend that everything is straight. You don't have to show all the little bumps where the tape are, or little places where the sticks go crooked. We know that the sticks aren't super strong. So we're going to pretend this all goes straight. And so I'll just go up here and make a mark like that, and a mark like that, that I can then connect. I'm going to draw the lines after I fold out this box, right? So that I can get them good and straight. I'll use a straight edge and get them good and straight. But for now, we have the critical parts marked off, where that corner is, right? And we'll go over to this side. Now looking from the right side. Once again, we're looking to see the places where the projectors would line up with the object. Okay, so I'll go right here with this projector. We say right there, that's the front, right there, that's the front edge, front corner of that right side view. Okay. And then over here we'll do the same thing. This is the back corner, back there. All right. That looks pretty good. Again, we'll go up here. And, well, I'm going to pretend that the thing doesn't twist. As it in real life, this tower twists a little bit, but in real life, if it was good and straight, we would just see the one side here. The other side would be behind it. We'd see the other side here. Okay. Good. So now we can lay out the glass on the table and draw those other lines. We should see a difference. Because this right side view is not parallel to the plane of projection, there should be a certain amount of distortion visible when we actually draw the right side view compared to the front view. Okay, so we'll move that. I'll lay this down. Got my piece of paper here. Pieces of paper. So we get a good contrast. I'm going to put some paper underneath the glass, and I'm also going to change the position of the camera so that you can see what we're looking at. Okay. Sorry, I missed that. Okay. Well, we'll fill that in. All right. Next, let's go ahead and change the position of the camera and see how this looks. Right. I'll slide it up just a little bit. All right. So I'm going to use a straight edge here to connect these dots. This is the front view right here. Oops. Messed that up, didn't I? Okay, and now we'll look at the right side view. One thing I forgot was the height of that cross piece. Okay, so that was somewhere right about here. Project that over to the other side. It'll look something like this. Okay. So that should be our our finished view of the sides. The reason I really am emphasizing this is to show you how, because in the front view, the side of the tower, the plane associated with this face of the tower is parallel to the front view, and thus is either not distorted or less distorted. Right? This line at the bottom should be the exact length of this line here. Right? On the other hand, because this is turned slightly, we know this is an equilateral triangle. We know in real life this is the same length. But because the plane of projection is not parallel to this view, this one ends up being shortened, right? And I can see the difference here. In real life, this is about 10.5 inches right here. You guys see that 10.5 inches for this distance right here. But in this right side view, we know that stick is the same length, but it's distorted because of the arrangement of the planes. That is about 8 3/4 inches. So that's called being foreshortened. And the position of these things is slightly distorted. This one is much more symmetrical overall, looking up. This is a little bit distorted, again because of that plane of projection not being parallel. Okay, this is a correct view for this type of tower. Has a triangular base, equilateral triangular base. In your drawings, I should see a difference between the front view and the right side view. If they're identical, then you have not followed directions. Okay, so hopefully you can get an idea for that, and that's the basics of the 3-view drawing, particularly with a tower that's basically a triangular shape. Okay, one last time to really get this reinforced well. We know that in the front view, this surface, this line, is parallel to this plane of projection, and thus this distance here is not distorted. It's the actual distance. It's an equilateral triangle as on the base of the tower. These are right angles to each other, so that this side is not parallel to that to that plane of projection when it's in there, and thus this line is distorted. It's shortened. The term is foreshortened. So here we can definitely see this line here, we said before, was just about 10.5, and this line in the right side view, even though we know in real life they're the same length, it's distorted by the system here. That's 8 3/4 inches long. So it's definitely a noticeable distortion. When you draw yours, be sure that you're following this convention. It also creates a little distortion in the visualization of the right side as well. Even though we know the right side is really just like this, again because of the position of the plane of projection, there's a distortion there. And this is pretty accurate as to what it should look like in your actual drawing. Okay, so please pay close attention to that when you draw it.